presenter. And now the floor is yours. Mr. Martin Valdez from European GNSS Agency, GSA. Thank you very much.
Okay, sure. So good morning, everybody. For us, at least here is good morning. So first of all, do you hear me? Do you see my presentation?
I have given you the presentation privilege already. It will take, I think, some time.
Yeah, but do you hear me?
Yes, I can hear you
Okay,
clearly.
good. Because I am sharing already, and so you should be able to see my presentation now. If it's not, then 1 second, I will try to do something else. Mhm. Okay. So apparently we have some issue.
But earlier we could see your presentation without problem. I think.
Yeah.
Okay, I'm once again giving you the privilege, taking it and.
Okay.
Okay, now you are the presenter. I think now you try once again.
Okay. So I'm actually getting a message that my connection to the server has been interrupted.
Oh.
But I see everything going on in the background, so I have some red screen. So, gosh, sorry about this. I don't know what's going on. It was working fine. Okay, we will get there. Right? So I'm going to. Come on. Cannot get rid of this red bar. Screen share connection to the server has been interrupted. Okay, I will reload the browser. Okay, so I'm back. Anita, do you hear me?
Yes, I can hear you, but cannot see your presentation. Can you send me the PDF of your presentation so that I can present from here, and you can. Okay. It's coming. Okay, no problem.
It's coming this time, right? Okay.
I can see your screen. Yes, now it's there.
Finally. Okay, I told we were going to get there. So I start again. Good morning, everybody. Thank you for the opportunity to present today here. Yeah. So as Anita was saying, my name is Omar Valdez. I work for the European GNSS Agency. We are the European agency in charge of the management of the GNSS systems of the European Union, in particular Galileo and EGNOS. And so today I'm going to discuss with you our work on low power GNSS position for IoT solutions. So let's start. So this is my outline for today. Yeah. So we are going to go through a bit of what is IoT. I'm not very familiar with the background, so please tell me if I am presenting stuff that is too obvious. Just let me know, and I will be glad to skip through some of the slides. But this is the idea. We are going to discuss what is IoT. But this what is IoT? It is from the perspective of the GNSS of the positioning system. Then the role of GNSS in IoT, and then what are we doing in GSA about this and about the GNSS and IoT. So let's start. Yeah, the first part. So what's IoT? So now, from our perspective, we have one of the things when you work with IoT is one of the most complicated things is to find an actual definition of IoT, because you have hundreds, depending on what author, book, paper, website you are reading, you will have a different definition. Yeah. So therefore, we have from our point of view, we have decided to adopt this definition, yeah, which is the connected things that communicate data, yeah, data about themselves, yeah, to either their manager, so the manufacturer, the operator, the owner of the solution, whoever it is, databases that are collecting data for different analytic purposes, and even between objects, yeah, the own objects themselves. So these objects may be what we call assets, meaning things, yeah, actual things, objects, yeah, like I don't know, like refrigerator, like yeah, you name it, wash machine, whatever, you name it. Yeah. Or we are talking about livestock as well. We're talking about animals, yeah, and for farming and for these kind of things, or even people. Yeah? I mean, here we're not trying to be pejorative toward people, saying that people are things, but from this concept, from the concept that we are managing, people can be treated as objects that are being tracked. So again, what can be connected? Yeah. So we have transport applications where you can have connected vehicles. And it is one of the trends now with the new generation of cars and even trucks and other big vehicles for the road. Consumer electronics, such as I mean, as I was saying before, refrigerators, wash machine, anything you name it. Then for healthcare, you can have the people who will have these devices monitoring their health, that are reporting to their doctor, to the physician, and this kind of things, or even to people who are concerned about them. Intelligent buildings, like when you have for heating, here in Europe, you have the problem that the heating is quite expensive. So you might want to keep your heating actually smart, so that you don't spend too much money. Manufacturing and supply chain, you track the stuff that is being produced and that is being treated through the workflow of a factory. Retail, you name it, yeah, wireless payments. We have even cards, supermarket cards that can be connected, and these kind of things. Smart cities, public transport in particular, so that you can monitor fleets. There are cities, for example, Luxembourg City in the Grand Duchy of Luxembourg. They have their whole fleet of buses monitored and tracked, so that they can regulate the times, the waiting times, and the frequency of the buses. And even the utilities, such as water meters and these kind of things. So for you to have a good reference, this document that I presented here is the GNSS market report. It's a document that we issue every second year, where you can see the perspectives that we have from the different markets. And actually, this presentation is largely built on data coming from this source, if you want to have more details. So the IoT infrastructure can connect many GNSS segments, as we were saying. So you have here you have and this is what I was telling you, yeah, that we are analyzing here IoT from the perspective of the GNSS device, yeah, of the GNSS service. So we have so first, from the GNSS market segments, this is the layer that you see in the middle, is how we segment our markets in this report that I showed before. So we have timing and synchronization infrastructures. You have LBS, location-based services, maritime, aviation, rail, road, agriculture, and surveying. And then you have the IoT application, the ones that I just mentioned before, that can interact with these market segments, yeah, or that are parts of these market segments. and then we have to make the mapping between them. And this is what is this is what I was why I was saying before, that it is important to make the segmentation from our perspective. So then, what is the installed base of connected devices as of today, actually, or the forecast that we have right now? Is we have for wide area IoT, we are talking about hundreds of millions, even billions of devices, yeah? And so the wide we have the wide area IoT, where we are expecting where by 2016 we had something as 0.4 billion devices connected, and we expect that by 2022 there will be something like 2.1 billion. Yeah, short range IoT, meaning the devices that use Bluetooth or these kind of things. We were talking about 5.2 billion by 2016. Now we're talking about for 2022, 16 billion. Yeah, then we have PCs, laptops, etc. But these are the segments that are the parts that are more interesting for LB for IoT. As you can see, the growth is quite high, exponential, and so it is. Therefore, this is a very good market opportunity. You have this is another reference that you might be interested in, is the GNSS User Technology Report. In the latest version, we went a bit further down into IoT technologies, and it's another source that you can grab from our website for free, and it can be useful. Again, this presentation is largely based in these two sources that I mentioned before: the market report and the technology report that we issue. So now we are getting more into specificities. Yeah, for an IoT device has basically a processor and a power source, a processor, and sensors. Yeah, without sensors there is no IoT. Yeah, and so this I guess I'm not telling you anything new. So the idea of the sensor is that the device can interact with its environment and with its with its environment, and so that it can gather information, it can gather data. And so you have many types of sensors. You have sensors that can measure humidity, chemicals, flow, etc. In this case, what we are doing is, or what we have noticed is that this industry treats positioning as one of the sensors that there are in this kind of applications, and therefore this is exactly where we are, and so we are concentrated actually in this kind of in this part here in the position and presence proximity, which is the part where GNSS can be useful for IoT. Yeah. So here you have several layers. As we have segmented the devices from our perspective, you have the application layer where you are interacting with the user. Yeah, you have the data processing layers where you are interacting with where you are actually producing data. Then you have the network layer, which is the communication. If you don't have communication, you have no IoT. And then you have the sensing layer, which is, as I was saying, the one that allows to interact with the environment. And this is where we are operating with GNSS, yeah, in the sensors. So, some characteristics of IoT objects. Yeah, so they are wirelessly connected to a network. This we put it like that in parentheses because it's an obvious one. I mean, if you don't have a wireless connection, then it's not much interest having the device connected. Then they generally do not have or do not need a user interface in the sense of the data of the connection or the connectivity. Yeah. You might have a user interface and a typical user interface for what we are used for networking and computing. Yeah, because you might have, for example, a wash machine. The user interface are the buttons that you have, and this is still a user interface, but it's not in the user interface in the sense that you have a screen with a touch screen or whatever it is. Yeah? So they are untethered. So they need to operate autonomously for long periods of time. This is a critical characteristic of these devices, is that they need to be operational for long times without maintenance. Then position if needed, whenever position is needed, is required either on demand. I mean, you want to know where the device is now, or from time to time, but with a relatively low frequency. And this is a key aspect of these devices that will be used, that will be very useful for the solutions that are proposed for GNSS to be adopted in the IoT world. Yeah. Then the position when required does not generally need high accuracy. Meaning here we are speaking about centimeter for us in GNSS, and this is important. Yeah? For us in the GNSS world, high accuracy means whatever it is below 1 meter. I know in other technologies, from other technologies, high accuracy for position might be something different. Yeah. Some applications that are using other position technology might be perfectly happy with 100 meters, for example. So this is the point. So in GNSS world, we are quite demanding. Then they must be cheap, because very often the devices are they have to be adaptable. They can expand, they can grow, they can be used many times. They have to support a rough environment. They can be dropped, kicked, moved around, etc. And they have stand to harsh environmental conditions such as dust, humidity, and they can even very often they are even disposable. Yeah. So you don't want to have a device that you will use once and you will spend $10,000 on it. Yes, it's not really. It's not what you can. It's not typically a solution that you can afford. And then they can be located indoors or outdoors. This is important because GNSS is basically for applications that are outdoors, as you may know, or at most they are very close to windows. That's why you can use a telephone with a GNSS in your car, because it is relatively close to the windows, and then you can access to the GNSS signals. So now, this is the IoT vertical segments. Now, this slide here is the result of a work that we did a couple of years ago, where we tried to segment the IoT market segment, and it was a nightmare. Because, as I was saying, depending on the source you consult, you will have different segmentations. Depending on the purpose that you are using, you will have different segmentations, and it really makes this work very, very challenging. So here we have some examples of vertical markets. One of the best classifications that we managed to get to, where you have personal wellness, smart homes, retail, offices, smart manufacturing, smart energy, work sites, etc. But really, this list really goes and goes and goes and goes. Yeah, it's really complicated to find a precise fixed segmentations for the IoT market. So now let's move now to the second part of my presentation. Now here we start getting more into the topic. Yeah, we get into the GNSS role in IoT, and so you can have several technologies that are providing that can be used to provide positioning for located things, for locating devices in this world. So in this case, you have, for example, you have the cellular network-based, the so-called cell ID that you might be familiar with, where it is used to identify to more or less find out the location with a singular find out the location of device emitting a cellular communication emitting a cellular communication based on the cell that it's connected to. So if you're using a single cell, then you know that you have a radius of around 5 to 6 kilometers. So then you know that this phone passed a call through the cell number 3036, you know that this telephone will be in a cell in a radius of about 5 to 6 kilometers from the cell. If you use triangulation, you can get down to about 200 meters, yeah, but it's still a very coarse, a very coarse location. Then you have the low power one, yeah, the low power wide area network, and there you have with the technology you have today, you are in a range from 1,000 to 2,000 meters for RSSI, and for the TDOA you have about 500 to 1,000 meters. Then we have here handset based. So basically here you're not using anymore the network, the communication network, to measure the position, but you are using a device that is dedicated in the device, a solution that is dedicated in the device to provide positioning. And the first one that is GNSS, the one we are speaking about today, and assisted GNSS, where you are between 1 meter to 50 meters, yeah, something like that. And then you have we have namely infrastructure based, where you have Wi-Fi, Bluetooth, and in general local technologies, where you are really in very low precision accuracies, but you need to be a high proximity from the object. So okay, so then this is what I was saying. We have the we were discussing this. I already discussed it. So here you have it in the presentation, written what I just more or less said. Yeah. Now, IoT tends not to be a friendly environment for GNSS. Yeah. The first barrier to GNSS to enter is the power consumption. GNSS has been historically been perceived in this community as a power sink. Yeah. Whenever you have to use the GNSS receiver, it will reduce the battery life of my device exponentially. Yeah. Then it is highly used for outdoors, yeah? So and for indoors in very particular conditions, as I was explaining before. And then there are alternative locations that the technologies that exist, and this is important, yeah, because the thing is, you have for example, the cell network based that we were discussing before. If you already have a cellular modem in your device that you are going to use to communicate, and therefore you have it anyway, then you might want to use that modem for as many things as possible, yeah. Positioning being one of them, even if it is coarse. So depending on your application, you might be happy to stay with this. Right? So again, in the IoT world, GNSS is a sensor that provides accuracy PVT outdoors, as we were saying before, position, velocity, and time outdoors. Yeah, and it is perceived, as I was saying, as an energy sink. Yeah. So far, the benefits that GNSS can afford, which are high accuracy position outdoors, high accuracy time outdoors, have not outweighed the cost in power that they imply for the solution. So, but still, GNSS technology is attractive in this sector because of three characteristics that it can provide, that it can produce. The first one being ubiquity. Yeah, the GNSS systems are designed to be available everywhere. Yeah? They are global, they are worldwide available, they are free. So therefore, you can use them whenever, however you want, as long as you are, as I was saying, outdoors and close to the outdoors. Then the accuracy of GNSS is unrivaled. Yeah, we are talking about meter, even sub-meter precision under good conditions, with a single frequency, single constellation receiver. Yeah, which is actually very good. Yeah, I mean, it's really something that makes the solution very, very attractive. Yeah. And then there is the security, yeah, and the security aspect is something that in our constellation Galileo is going to address in the future with some added value services, in particular authentication and other solutions that can be useful for this community. Yeah. So we move on to the next slide. Yeah. So this is the perspectives that we see for the use of GNSS in IoT. Yeah, in the mid and short term. Yeah. So you see that we see that there are quite some hundreds of millions of devices that are forecast to adopt this technology. You see our graph, they finish in 2021 because these graphs are still taken from our previous edition from the market report, but you might want to get the latest one, the one from the for the most recent one. Yeah, that was just sorry, this is from the technology report. Yeah, and so you might want to get it from the latest version, yeah, the latest edition. And now this is as I was mentioning, this is an important source. It's our GNSS user technology report, and then from here we have found really that GNSS is being used more and more, and we think that it can still be used, that it can be still be further adopted. Yeah. And so you see the dimensions. We are speaking about very small solutions with a current consumption that is relatively low, except for certain phases of the operation of the receiver, which I am going to get into later. And then some specifications that you see, they make it quite interesting. So we think that there is room for GNSS to enter the IoT market, and for this purpose, we have published a white paper that where we studied these technologies, the technologies that can be useful for GNSS, and the methods that can be applied in order to make a GNSS an attractive solution for IoT. So this source again is free as well in our website, and the discussion that is going to follow is largely based on this white paper. So if you are interested, you might want to go to our website and download to get the whole thing. So one of the things that we have in this paper is that we have written there a decision tree to see if GNSS is appropriate for the solution that you are thinking about. So if you have low position accuracy, meaning kilometer level, as we were speaking before, yeah, and you will anyway have a telecommunication modem because you will need one in the solution, then you might want to stay with that solution, yeah, and be happy with it. Yeah. So therefore you don't take care about GNSS. You put only one modem. You use it for communication and for location. Yeah. And then it's an optimization of use of power, which is the most precious resource in this domain. Now, if you need precise globally available position or time, you will put here position, but it also applies for time. And if you have position and time, you can have velocity as well. Yeah, but if you need, let's say that you need precise position, yeah, then you might want to go for GNSS. Yeah, yeah. So if you have an accuracy of a few meters, yeah, then you can use multi-constellation receiver with single frequency. The multi-constellation is because you don't want to have a single point of failure in your solution. So you have, for example, you can use GPS, you can use Galileo, and then you have a system that is more robust with the same cost, basically, in energy. So then you have you use a multi-constellation single frequency. You will have a solution that is where you are speaking. I mean, if you have a cargo ship in the middle of the ocean, yeah, if you have a few meters, even accuracy, that is quite good. Now, if you need some meter accuracy required, for example, you want to have cars that are able to drive on their own, yeah, then you want to consider multi-constellation and multi-frequency GNSS. And this is how we advise that you can decide how and when to adopt the technology. Yeah. So this is your case. Now in IoT, it's all about battery life. Yeah. Autonomy in this domain is key. Yeah, I mean, you want to have a solution that will stay operational without maintenance or with a minimum of maintenance for as long as possible. This means that you need a very long battery life. Yeah. Then, as I was saying before, GNSS has been traditionally perceived as a power sink in the IoT world, and this is not quite wrong. Yeah, and it is due to basically two operation phases in the GNSS receiver. One is the signal acquisition, and the other one is the data download and the processing of that signal. So in particular, the second one, yeah, it is due to the low bandwidth or the low bit rates that are involved, where you need to keep the receiver, even if it is not consuming too much power, but you need to keep it on for a very long time. Yeah. Now, I have now here a slide that is a bit more technical, yeah, but it's because it will be useful for discussing signal acquisition. So this is a very short introduction to how GNSS works. So I don't know if I'm not quite familiar with the audience, so I am going to go through this very quickly. Yeah. So this discussion that I'm going to give is applies basically to all of the GNSS systems that are today operational, meaning GPS, Galileo, GLONASS, and Beidou. And it starts by the user being lost somewhere. Yeah, so the user doesn't know. Doesn't know where he or she is. Yeah? So you can see this guy, this fellow here. Yeah, completely lost. And then GNSS is based on the triangulation principle. Yeah? So if you know your relative position to 3 points, yeah, with that with no position, then you can figure out your own position. Yeah? So this is the basic operation of GNSS. Yeah. So this principle is operated using the simple geometric distance, yeah, that is calculated towards a satellite in orbit around the Earth. You see, this one is simply the geometric distances. Yeah. So you have the geometric distance from in the x-axis. I did this in XYZ to simplify the math. Yeah, usually in real conditions you use polar coordinates. Then you have xu. Yeah, so this is the x coordinate of the user, and this is the x coordinate of the satellite one. The y coordinate of the user, the y coordinate of the satellite one, the x coordinate of the user. So you see, this is simply the geometric distance. Now, how to calculate this distance is based on a very simple physical principle. Yeah? It's basically, the propagation speed of the signals that are emanating from the satellite, which is basically close to the speed of light, and we use speed of light actually for the purposes for this discussion and for practical purposes. Sorry. And so what you do is you simply take the velocity of the light, and you divide it by the time of propagation, which is the other part that you need to know, and then you have basically the linear distance. Yeah. So this is what you have here. Yeah. The velocity of light multiplied by the time of propagation between the satellite 1 and the user. Same thing for satellite 2. Yeah. And so once you do this, yeah, you have once you do this, you have you have here the satellite 1. You know the distance to the satellite 1, but then you have so I will explain a bit about the element. So how it goes is, in the user you have a very cheap clock, so that the receiver is affordable, that it costs basically a few dollars, meaning not even tens of dollars, but really units, so units of dollars, very, very cheap. Yeah. And in the satellite, you have a very precise atomic clock. So what you do is that you have to synchronize these two clocks. So one of the parameters that you have to find out when you're making this operation is the difference between the times. That is what I have called here the clock offset, which is this term B, which is basically the difference between the time that the signal left and the time that the signal right. You have this time offset, and then this becomes one of the parameters that you are going to look for in your equations. So Now you've figured out the distance that you have from this satellite. That means that you can be in any point of a circle around this satellite, which is not very useful information. You will agree with me. Yeah. And so how do you improve the situation? So you add a second satellite. Once you have the second satellite, what you end up is with two solutions. Still not very useful because you might be here or you might be here. Yeah, so meaning you may be where the user is or you might be somewhere in outer space. Yeah. So how to solve this is, again, you add a third satellite, and then you have a single intersection point, and there you know where the satellite, where the user is. Yeah. So, and now what you have when you have three satellites is that you have a very nice set of equations where you have three equations with three variables that you can solve. Yeah. And now this solution works quite well on paper. Yeah. Literally, because it is a solution for 2 dimensions. When you want to have a 3-dimension world, what you do is you add one more satellite, and that's why you get this famous number of 4 satellites that you need to get a fix, the minimum amount of that you get a fix. You need to get a fix. So I gave you all this introduction because I wanted to take you to this point. Yeah, that here is there is a catch here. Yeah, is that these satellites are moving. Yeah, and they are moving quite fast. Yeah, and this is so basically you have to know the position of the satellite, and that you will find out through the contents of the navigation message, and you have to be able to compensate the fact that the satellite is moving. Yeah. And this is where we get to the challenge of signal acquisition. So all the discussion that I gave you here is to take you to why signal acquisition is a problem for IoT. Yeah? So for signal acquisitions, as I was saying, the satellites are moving rather fast. Yeah? So now we are speaking here about the speed of light. Therefore, the time delays are very small. So you have relativistic problems in this relativistic effects when you have making these calculations. And that's why you have to take into consideration the Doppler effect. The Doppler effect it varies according to the relative position of the satellite towards the user. So you know if the emitting object, in this case the satellite, is approaching towards the user, then the signals will tend to be shorter in bandwidth, and if it is going farther away, they will tend to be longer in bandwidth. So this results on actually a frequency span, a bandwidth, where the satellites might be at any given time. You need to look for them in the space. So another challenge that you have here is that the signals of GNSS are intentionally broadcast in very low levels that get confused so that they are hidden in the environmental noise, in the electromagnetic noise. Actually, that's where the name of pseudo-random noise code or PRN code comes from, because the signals are hidden in this noise. So in order to get to this, in order to find these signals, you have to make a scanning through the Doppler space, yeah, and then you have to look for the codes, yeah, using a correlation operation, meaning you have to go to add many times one over the other the space until you get the obvious solution, yeah, which is in this case a satellite that is here. You see it here. Yeah. So for any of you who have worked in this kind of stuff and has had to done correlation for any purpose, you know that correlation is a mathematical operations that requires intensive computing power when you want to do it in a computer. Yeah. And if we are speaking about intensive computing power, it means high power consumption. And this is why the signal acquisition is very expensive in terms of energy. Then the other thing that you need to know is, as I was saying before, is you need to know where your satellites are, and these are coming from the data that is enclosed in the navigation message. As I was explaining before, the navigation message is long, and the bit rates that are involved are very low. Therefore, therefore it can take a long time to get the whole navigation message before you can calculate the position. Yeah, this is what is called the famous cold start. So, for example, for Galileo, the whole navigation message is broadcast takes 720 seconds. Yeah, which is you see is more than 10 minutes. It's more than 10 minutes, and this is quite long. So you have to keep your receiver on all the time, at least, in order to get a solution. Yeah, and so you need all that, yeah, in order to know where you are. Yeah, and this is exactly what is challenging for GNSS to enter this market. So now, after that small detour about GNSS specifics, we come back again to the GNSS integration to the IoT. So we have identified 3 technologies that can help overcome the challenges that I explained before. Yeah, the first one and the most well-known maybe is assisted GNSS. In assisted GNSS, you have an auxiliary data channel that is feeding data to the receiver, so that it doesn't need to download the whole navigation message every time that it needs to calculate a position. And this is usually an effective solution for IoT, because you have often a communication modem that operates at a higher bandwidth than the one that is that is in the one that is higher bandwidth than the one that is used in the GNSS satellites. And so the transfer of data can be more efficient through that way, giving you the opportunity to keep the GNSS receiver on for shorter time. And then you can, of course, you can add the data there, like extended ephemerides that will allow the receiver to estimate the position of the satellites when it's going to make the scan that I mentioned above. It can predict the position of the satellites to a certain extent, and then that can make the search shorter. Then you have a second technology, which is the transmission of pseudoranges. Yeah, the pseudorange is actually the initial calculation is basically the raw measurement that you get from the when you make the GNSS receiver. So you take the pseudoranges and you transfer them to a different solution, to a different platform. For example, a server or that is based in the management where the device is being managed. So this is feasible because quite often you don't need the device to know its own position. You need someone else to know the position of that device. So you don't actually need to make all the processing on the device, but therefore consuming a lot of energy. You can actually, again, profit of the communication model that you have anyway, and send this data somewhere else, and process it somewhere else, and then calculate the position somewhere else. Yeah. And then another trick that we know, I mean, I call it a trick, but it's actually a technological trend at the moment, is the snapshot technologies, which is combining the two ones above. You just switch on the device. You don't use continuous tracking. You just switch on the device from time to time whenever you need it, whenever it is acceptable to the application that you are using. I mentioned before the example of a boat, yeah, that is going through in the middle of the ocean. So if you have if you calculate the position once every 1 hour or every 2 hours, that should be enough. You don't need to really be calculating the position continuously, because you will know that, okay, so now I open the receiver now. Then when I switch it on again, the boat is 10 kilometers or 15 kilometers further away. Yeah, 5 nautical miles or something further away, and that in the immensity of the ocean is nothing. So you can actually track your object like that. Again, this depends on the application that you are using. So here are the discussions, yeah, of what I was just of what I just said, and now we can move forward. Yeah. Now, these techniques that I described before work. Unfortunately, when we made the screenshot of this slide, it didn't went quite right, quite clearly. But if you want to see this figure with more clarity, you can see it in the white paper that I mentioned before. Yeah. And here you can see that when you are using, for example, ephemeris data from server, you can when you're using the technologies NB-IoT or LTE, you have reductions of 10 times of the power consumption. Yeah, from the GNSS receiver. Right? We're talking about the GNSS receiver, not the total device. Yeah, when you're using autonomous ephemeris, then you have 3 times reduction. Not as good, but it's actually even not too bad. Then, when you are processing the pseudo ranges already out of the device, then when you are using low power line like Sigfox and LoRa, you have 2 or 4 times the reduction of the power consumption. If you are using with more bandwidth, the technologies like NB-IoT or LTE, then you can have up to a factor of 10 reduction in power consumption. And then for snapshot technologies, I mean, you can even get down to 25 times again in energy from the GNSS receiver. This really starts making GNSS an interesting technology for these solutions. Now, we are talking about multi-constellation. There are many systems around. Yeah, my job is actually to promote the adoption of Galileo, and therefore, in this case, it's not. I'm not doing this only because it's my job, but because we really believe that there are some advantages of using Galileo of your solution of choice. Because, as I mentioned before, we will have in the midterm, we will have authentication, which means that you will be able to certify that the positioning that you are using is being calculated from signals coming from space and not from fraudulent signals posing as a satellite. And this will be implemented relatively easy thanks to the OSNMA approach that we are going to put in place. OSNMA means Open Service Navigation Message Authentication, and it's going to be disseminated on the Galileo frequency. You will not need any modification to the radio front end of your application. It will be basically a modification only on the receiver layers, yeah? And it will be open. It will be for free. And then another differentiator that Galileo will introduce will be the high accuracy service, where we are expecting to go down to 20 centimeters for positioning, which is actually quite good. And for this purpose, you will need for this service, you will need a different receiver because you will need a triple frequency receiver or a double frequency, but using different frequencies. And but it can be very useful because you will have actually coverage even to high latitudes, something that you don't have with the SBAS technology. Yeah. So now I move now to the last part of my presentation, which is our approach to attack this issue, which I think somehow I already explained a bit in previous slides. Yeah, we are focusing on GNSS relevant IoT domains. Yeah, so basically, we are, you remember all this massive segmentation that I showed you before. We are concentrating on these four segments. You're talking about consumer tracking, professional tracking, smart cities, law enforcement, robotics. Yeah. And so in consumer tracking, we are talking about tracking pets, about tracking elderly people who live alone, who might have accidents, tracking children as well, and when children go with schools in school trips, it can be useful to have devices to track every kid. Sports trackers are actually quite an interesting market right now, and then for professional tracking, we are talking about, as I was mentioning before, the tracking of goods in high sea, in containers and in boats, and fleet management. When you have fleets of boats fleets of containers, fleets of buses, these kind of things. And then for smart cities, we have actually seen some interest from smart lighting, which is basically some cities want to put GNSS receivers on their lights on the lamppost. It's an interesting idea. Smart energy, in the sense that you try to use solutions for optimize the consumption of energy, waste management, and other applications that we have seen in smart cities. For law enforcement, we are speaking about geofencing trackers, which are already used for house arrest, for example. And then for robotics, we are speaking about gardening robots, which are quite useful. The delivery robots, so that are the trend, and drones even, yeah, and security and surveillance. So, as I was saying before, it is important that we segment the market from the perspective of our solutions. And for this purpose, what we see is that we have to split all this marketing in three parts. We have the high end, the mid range, and the low end. And the high end, you have devices like our LBS, like this is what we use here. Then you have really devices that have power availability, or that have power available, and that you can maintain easily. For example, smartphones, drones, and these kind of things that you can plug every time that you need it to charge them. So then we have the mid range. Yeah. So here we are already speaking again of things that have power available, but to a lesser extent to the ones above. And we're speaking about here asset tracking, wearables, bike sharing. You know, these bikes that you can find in the cities, and that actually, when you are pedaling for the bike, you are charging the battery of the bicycle, for example. And they in this domain, they still tend to be use largely GPS only, but they are moving, and we expect them, they will move to multi-constellation. Yeah, they are open to GNSS because they have power. Yeah, and the challenge that we see is promote adoption of Galileo as either the second constellation or even the constellation of choice for single constellation. And then for the low end, we have today there is no GNSS. We are talking here about what I was mentioning before, disposable solutions, for example. And then for tomorrow, what we hope is that we will have these innovative concepts that I described before. Will promote the adoption on this segment. Yeah. Then the IoT challenges is okay. So this is a summary of the slide before. Yeah, and then the main, for the high end, the main Galileo weakness is acquisition, because acquisition of Galileo takes a bit longer than other constellations, particularly GPS. Then for the medium end segment, we have the challenge that it's that they have options for this medium segment. What happens is that they have options, so they don't need to go exactly. They are not forced to go on GNSS. They can use other options, as I was explaining before. Yeah, because very often they have LP1. Very often they have Wi-Fi. And in this case, for the low end, is at the moment we have very low no adoption, and this is what we are actually now working. We are funding projects to foster the adoption of in these solutions. And if you are more interested, if you're interested in any of these projects, if you think that you could be interested in this project, just let me know, and we can make an introduction with the companies running these projects. Now, here these are the technologies that are candidate that can be used on IoT. Yeah, and here again you have several options, like the transmission of raw snapshots, what we discussed before, and those make the attractiveness very high, and they have very high energy efficiency. So in this graph, you have all these technologies distributed by this compromise that you have to do between energy consumption and energy use and network use, which is also critical when you are using remote processing technologies. You have to take into consideration the network use as well. So the RNA3, yeah. So in this table here, the R and A3, the two ones that are in the low, yeah. So they will ensure full acquisition, tracking, and PBT on the receiver. Yeah, they tend to do that, and they have very little use of network because they do all that basically in the receiver itself. Right? So now, okay. Again, what's the landscape today for these technologies? Is that the LP1, they are limited in bandwidth at the moment. So basically that leaves us an opportunity, window of opportunity to enter in this sector. Yeah. And then they make it complicated for the technologies that require the full transfer of data. Yeah. And then on the receiver side, the traditional acquisition is still the most power hungry task, as I was explaining before. And then the technologies that are using this, that are addressing this issue, are assistance, as I mentioned before, because you have additional data that can help the acquisition phase to be shorter, and the snapshot, because you don't need to keep the receiver on for too long. Yeah. Then here, so here you have a slide where we discuss the points above, yeah, and the points before. I will not go into details of this. Yeah, if you want, you can read the slides after the presentation, because I think we are already have been speaking for almost 1 hour. Yeah, and so. How do we see the future for these technologies? Is that we think that we are moving towards remote processing and sorry, we are moving towards remote processing of a snapshot of raw measurements. Yeah, basically a combination of all the technologies that we mentioned before that will make the power efficiency very high in this sector. So now I start closing my presentation. So first, I would like just to highlight that and to really make the emphasis that GNSS is a viable solution for tracking objects in IoT. It has to be really taken into consideration. The main power consumption saving techniques that have been developed recently is the transmission of pseudo ranges and snapshot techniques transmission of pseudo ranges for remote processing and the snapshot techniques, and the combination of both approaches makes even more power efficient solutions, as I was saying just before. Yeah, in terms of accuracy, we have the multi-constellation, multi-frequency receiver. Yeah, we are speaking here about accuracy of less than 1 meter. If your application do not require such frequency, you can be happy, for example, with multi-constellation and single frequency receiver, and there you are in multiple meter. But again, it depends on your application. It depends on your needs and what you want to do. So that's it from my side. I don't know if there are any questions. Hello.
To also make your video on so that the participants can see you.
Yes.
Okay.
Yeah, so okay. Yeah.
Okay. First of all, thank you very much from all of us here, the organizers and the presenters, all of us together for your nice presentation. Because of the increasing dependence and requirement of location-based services, basically satellite-based navigation-based services, and amongst the attendees, there are many who works on this particular technology, and obviously other participants who are working on sensor technology or IoT, for them it's very important. And as highlighted by Omar, I would request everybody to download the documents from the GSA website, which can give you the insight of the market. For the participants, this was a very important lecture, I would say. Along with the technology, what are the, I would say, implementation techniques, and what are the issues related to it that has been discussed. So first of all, now the floor is open for any question. Any participant who have some question, please type your question. I will read it out for Mr. Valdez to answer if you have any question. Hello, if you have any question, please. So if you do not have, still can type in your question. I have a question for Mr. Valdez. That other than the cellular phone-based GNSS sensors, which are very cheap, the other GNSS external sensors, still now I think we cannot get anything, even the single frequency ones, below $10 or $7 or $8, not below that. How do you look that what would be the competition among the manufacturers, so that the cost becomes lower, and we people who deal with development of GNSS based solutions using external chips that would come into the near future?
This is I mean, this depends on what you mean by an external chip. Yeah? Because we have projects that are aiming at providing solutions where the GNSS part will cost €1, yeah, which is roughly $1.15, I think, something like that nowadays. Yeah, and this is but this is only the purely GNSS. This has to be integrated into the onto the whole device. Yeah. So we hope that at least lowering the cost of the GNSS part might make the overall solutions cheaper, and that's why we found this R&D project. And for us, it's very important that they present us business plans where they can show that their solutions will have a market, and actually lowering the price is one of the things that we consider. But yes, we expect that in the midterm the prices will go even lower.
Okay. Okay, thank you very much. And obviously, as because we are talking or organizing this from India, I should mention here about also along with the global systems. Now we have got QGIS and also NAVIC, which can be used, and also we have worked some with the integration of NAVIC with Galileo. That how Galileo and NAVIC, they can play some complementary role from the viewpoint of visibility, coverage, and also improvement of solution accuracy. We have done that, and we hope that obviously in the Indian subcontinent and within the coverage area of NAVIC, both Galileo and NAVIC, they would supplement each other. Already we have some work, it's under consideration of publication, and definitely we will communicate you because we presented that in GNSS Asia Forum. that it has got definite advantages when we are integrating Navic along with Galileo.
Okay.
That's the comment.
So you're asking me to comment?
No, that was a comment from my side. So if you want to comment on it.
Yeah, no. The interoperability, yeah, it's one of the key words on the location domain in general, yeah, because the more solutions you have in your solution, the more robust your solution is, yeah. So it's very good to hear that there are efforts to integrate and to integrate more technologies. And this, for example, this integration and interoperability can be seen. I give you an example of one project that we are working on. These guys, they are developing the low power GNSS solution for IoT, yeah, but they are not developing a device that is going to be separated. So they are developing is just the hardware and software description of their solution that then they are going to license to companies that are producing, for example, LP1 modems, yeah. And so these guys will be able to integrate that into the same chip that they are using, and then you will have a single integrated solution. And the only thing you will have to do is to add an antenna. Yeah. So
Okay.
integration is key for volume, for power saving, for volume saving, for weight saving, for everything. Yeah.
Okay. Probably there is one question. Let me. Okay. Mr. Dr. Rajesh Jain, he has complimented you for the nice lecture. There was
Thank you.
no question. So if there is no more question, you are getting opportunity to talk. Oh, I have one more question. How do you see that in very near future in markets like India, the UAV and the drones, for specifically keeping in view of the pandemic situation for packet delivery and in future medicine delivery, they are going to play, what would be their role in this type of pandemic-like situation where maintaining physical distance is very important? How do you see, and what would be the role of GNSS in such applications?
Well, for delivery by drone, I think it's really a typical, very good, clear use for GNSS, because it is an outdoor positioning. You need high accuracy, because if you are making a delivery with a drone and you are going to drop a packet in front of the door of someone, and you have an accuracy of less than 5 meters, you might end up at your neighbor's door. Yeah. So this is really a good example of an application where GNSS will play or will play a very important role. Now, how important the delivery by drone and by UAV will be, it is going to depend as well on regulations, because the drones, these drones tend to operate on the airspace, and depending from one country to another, you are speaking where countries where in order to fly above 30 meters, you need a license. Yeah. And meaning, if you are speaking about 30 meters, that means that that is roughly a 10 stories building. Yeah. So you cannot go over a building that is higher than 10 stories. In crowded cities, that can be a problem. Yeah. So I have seen as well some other delivery robots that are drones that will not be for flying, but that they will walk or that they will drive on the sidewalk. Yeah, and that's another option. But yes, I think it's an application that is really very interesting. Yeah. So far, I haven't seen in our calls for projects any project coming about this, but I expect it's going to start coming soon.
Okay, thank you very much. So if there is no more question, thank you very much.